In my old age, I'm now wise. Well, not the same age as some of you. Okay, so or maybe younger. Chapter 4. So chapter 4 was applications of derivatives. The first section was discussed critical numbers. So critical numbers are where the derivative is equal to 0 or it's what? Undefined. Most of you missed that one. There was one on your test that, tested. Did you remember the or undefined bit? And yeah, some of you forgot. And the undefined part about critical numbers, the function must actually be defined there in the first place. So vertical asymptotes are not critical numbers. They are places where the sign of the derivative can change, but they're not critical numbers. And then you use this to find the absolute maximum. It's like the absolute biggest and absolute smallest y's of a function on a given interval. And to do that, you tested the critical numbers and one other thing in the function. Critical numbers, and what else do you test? You plugged numbers in once you find critical numbers. What were the other numbers you plugged in? The endpoints. Those are the two ideas in section 4.1. Yeah, well, hey, something. Find the absolute max and min of this function on the interval from -3 to 1. So what rule do you have to use to take the derivative of f? And also the product rule, yes. So first you differentiate x. Its derivative is 1, right? So 1 e to the x over 2 plus x e to the x over 2 times 1/2. Set it equal to 0, take out the greatest common factor. Do we agree with that much of it? 1/2 times x is x over 2, right? Okay, is the first component ever going to equal 0? Will e to the x over 2 ever be 0? Nope. So you're just solving 0 equals 1 plus x over 2. -1 equals x over 2. So what's x got to equal? -2. And just be aware, so watch out. Just check if this is in your interval. Most of you got that right in your test, but the test question that you guys did, there was one critical number you got that was outside the interval. You don't test that one if it's not in the interval. This one is though, right? So then we're going to test f of -3, f of -2, and f of 1. So f of -3 is -3 e to the -3 over 2, right? F of -2 is -2 e to the -1, and f of 1 is e to the 1/2.
E is between 2 and 3.
E is between 2 and 3, but I think the absolute max should be totally obvious. Which one's the absolute max? The bottom one. And that's obvious because the previous two answers are both negative numbers, right? E to the anything is positive. The question is, which is smaller? And I actually don't think this is a great question for you telling without using a calculator. So the first one is about -0.669. This one is about -0.736. It's not, they're pretty close together, so this is the absolute min. So to do my best to give you something on interval where you can actually interpret it. I mean, I like to give you things where you have to use the product rule, but I'll have to make it a little bit more obvious as to, without a calculator. Yeah, but what you're doing is you're doing -3 divided by e to the 3 halves, and then -2 divided by e.
out.
And so then it's less obvious which one is smaller, right? If the e's were the same number, then yes, it'd be the first one for sure, but yeah, it's not totally clear without approximating them.
So in order to make a problem with clear answers, do you start with the answers and just build the problem around them?
Usually I take problems from textbooks and then I just check them.
Oh.
I mean, or I modify them if I can figure out the way that they're constructed. But constructing my own problems it takes a long time. I could trust that I have a lot of textbooks. So I have lots of things that, I have an old textbook I used to teach out of, I don't teach out of anymore. I have AP tests that I gave in the past. And I think I have like 5 calculus textbooks at home.
So we just need to find all those textbooks and memorize their answer keys.
That'd be great. I don't think you need to do that though. That seems like way too much effort. Okay, find the absolute maximum, absolute minimum of f of x is x over 3 minus cube root of x on the interval from -1 to 8. Okay, so f of x, I'm just going to rewrite as x over 3 minus x to the 1/3. So what's the derivative here? Minus great. Set it equal to 0. That's 1/3 minus 1 over 3 x to the 2/3. So f prime is undefined at x equals where? 0. Do you agree with that right away? Because you can plug 0 into the original function, right? But you can't plug 0 in the derivative. That means there's a corner there, usually. I'm pretty sure that's actually always the case. If you have a number where you can plug it into the original but not the derivative, it's a corner. Okay, now for solving that equals 0, what would you guys think of doing next? Say that again? Pull out the 1/3? Okay. What do anyone else think of? Add. Can you add those two together right now as is, though? No, how about find a common denominator? Is that okay? Or you can do that, or you could move the, you could say 1 over 3 x to the 2/3 equals 1/3. Does that make sense? That's what you're thinking. Then you could cross multiply, and you'd get 3x to the 2/3 has to equal 3, right? The 3's can cancel. X to the 2/3 equals 1. So what does x have to be? 1. So are both of those numbers within your interval? From -1 to 8? Yes, okay. So then we must find f of -1, f of 0, f of 1, and f of 8. Okay, so -1, -1/3 minus the cube root of -1. Can you cube root negatives? Yes, what's the cube root of -1? -1. So this is -1/3 minus -1. So f of -1 is 2/3. Okay, so there's one of them. F of 0, easy. F of 0 is 0. Woo! F of 0 is okay, f prime of 0 is not okay, right? Okay. F of 1. That would be 1/3 minus 1, yes? So f of 1 is, so far that's the lowest, isn't it?
So far.
I don't know what the last one is. I've worked it out before, but not recently. So it's possible, yep. F of 8 is 8/3 minus 2. So f of 8 is 2/3. So it looks like the absolute max is f of -1 or f of 8, both of which are 2/3. And how about the absolute min? So how do you figure out where a function is increasing, decreasing? What do you do? What do you look at? Look at the first derivative, right? So increasing if first derivative is positive, right? Decreasing if first derivative is negative, right? How about concave up? What do you look at? Prime prime must be positive, right? Concave down, prime prime must be negative, right? Derivatives are how you prove where a function is increasing or decreasing. That's what they're used for. If you take calculus 2, you're going to use this to figure out where something is increasing or something is decreasing. You'll use that idea again. Okay, so given this weird g function, find the intervals of increase, decrease. So if you're going to look at increase, decrease, you got to look at the derivative, right? So first take the derivative. So g prime of x is 10 thirds x to the negative 1/3 minus 10 thirds x to the 2/3. So 10 over 3 x to the 1/3 minus 10 x to the 2/3 over 3.
Would it be easier to just factor out 10 over 3?
If you'd like to, I don't think you have to. I think the thing to do is get a common denominator. That's just me. What would you multiply?
That's because you really like home.
I like common denominators. I think they're really helpful, and also it's like a 5th grade idea that just generalizes, and if you can like do that. So I mean, also it's already half done. They both have 3 in the denominators, right? Someone tried really hard to make this problem somewhat easy. That someone was me. What do you multiply the second fraction by to make the denominator common? X to the 1/3. Like, this problem was doctored to work out for you. Like, seriously. You're welcome. I do try, even if I fail sometimes.
Applications be this easy?
Of course not. Which means if you can't do this, real life ain't really gonna go well for you. I mean, like, I don't want you building bridges if you can't figure this out. I'm so sorry. I just don't. I'm not comfortable with that situation. Okay. Yeah, that's why the overpass in Minneapolis collapsed. So, well, that's probably not actually why. Maybe they passed their calculus classes. So set this equal to 0. So first of all, where is this derivative undefined? And so then you can kind of ignore the denominator. And you're just solving 0 equals 10 minus 10x. And that has a really easy answer. X equals 1. Yes. Add 10x divided by 10. Yes. Okay, got that. Woo. Okay, so now you make your number line chart. Yeah, capital G prime's sign. So we have 0 and 1, and we pick test numbers. And probably easiest to test in that one. So like say test, I don't know, -1. So if you input -1, what's the sign of the numerator? And the denominator is negative. So overall, your derivative is negative on that interval, right? How about between 0 and 1? Like, I don't know, 0.5. Your numerator would be negative, I think, right? Because it'd be 10 minus 5, right? What's what the cube root of negative 0.5 is not important. The point is it's positive. Oh, okay, well, yeah, we're positive. That's what I thought. 10 minus 5 is definitely positive, guys. Yeah, what's your thinking? What's wrong with you? So that overall, that's positive, okay? And how about past 1? That's, say, like 2. Now, 10 minus 20 is definitely negative.
Sure.
No. Minus over plus, so minus. And your number line is not your answer. You have to give me the intervals, because it's not always, students sometimes will pull their test points from their intervals and not the actual end points. I want you to give me intervals. So G is increasing where? 0 to 1. And it's decreasing Mm-hmm. Union 1 to infinity. So you must do that last step. Okay. The work for part B is actually on this slide, so I'm not going to actually go to my next slide. I'm just going to do part B here. So part B says to find the local max and local min values. The number line tells you what's what, right? So at 0, is there a local max or local min? Local min, sorry, f of 0. And when you input 0 in the original function, you get out 0, okay? And at, is there a local max? At 1, yep, f of 1. And I believe that will equal 5 minus 2, right? Or 3. I will only ask you to not, if I want you to not find y, I'll say find x only. Does that make sense? Otherwise, I want you to find y. But if the arithmetic gets too tedious, I will ask you not to find y, and don't waste your time finding y if I say x only. Okay, local maxes and min.
Even though
0 is undefined for the derivative, but it's not undefined for the original function. So what that means is at 0, you have some kind of corner point. And I think if you were to graph this, it probably looks something like that. I mean, it ends up looking a bit like this. So the derivative being undefined can still be a max or min. Okay, intervals of concavity. Okay, so our derivative g prime of x was equal to, what was it before I got a common denominator? Uh-huh. Right, it was, and one of them was this one was negative 1/3, right? Okay. It's going to be easier to differentiate that guy than take the derivative of using the quotient rule, right? Okay. So g prime prime will be negative 10 ninths x to the negative 4/3, right? Minus 20 over 9 x to the two-thirds minus, you're taking the derivative, not the integral. So negative 1/3. I just like common denominators, so what do you can multiply by? How can you make 1/3 into 4/3? How much you have to add to 1/3? You add 1, right? Or x. If you multiply by x over x, 1/3 plus 3/3 is 4/3, isn't it? Okay. So you have 0 equals negative 10 minus 20x over 9x to the 4/3. So where is g prime prime undefined? At 0, yep. And then solving the rest of it equal to 0. So 0 equals negative 10 minus 20x. 20x equals negative 10. So x equals what? Negative 1/2. Great. Negative 1/2 and 0. Okay. So say we tested negative 1. I think negative. Do you guys agree with that? If you test negative 1 and you're testing in this expression, the numerator is positive, right? The denominator is negative. Okay, how about -1/4? So numerator is negative, denominator is negative, so yes, positive. Do you guys agree? Okay, how about testing something like 1? Yep. So G is concave up, -1/2 to 0. G is concave down. -infinity to -1/2, union 0 to infinity. And I guess it said find the inflection points, but that's just not going to happen.
And what do you say makes -1 a negative?
When you plug -1 into x, oh, I think we're wrong there. I think that's positive. It's to the 4th, right? Because first you third root it, then you make it positive, don't you? Because you third root, so that should be positive. So look, concave up there and there. Nice catch. Oh, scribble, scribble, scribble. So then is -1/2 an inflection point? No, concavity doesn't change. So where does the concavity change?
0.
And that one you actually could plug in. It's not awful. Oh, yes, G of 0. Everything's also always an F.
False stuff right there.
That is a little bit, yeah. How about this? 0, 0. Okay. So you were also given things like this where I gave you derivatives already, right? And you're asked to just use those to figure out what's happening with the function. So given this g of x function, that derivative and that second derivative, which part do you use to find the intervals of increase, decrease? G prime, okay. Okay, so first of all, where is this thing undefined? +3 and -3, right? Because that makes the denominator 0, yes? Okay. Then try to solve 0 equal the numerator. You get 9 equals -x squared, or x squared equals -9. Does that have any solutions? No. So g prime of x does not equal 0 anywhere, right? It's only undefined. So on your number line goes -3 and 3. And you're testing the sign of g prime. So how about testing something like, I don't know, -4? I think it's negative. Because you plug the -4 in the numerator and you get -25. And in the denominator you get 16 minus 9 squared. So I think that's negative. Do you guys, does that make sense? Okay, how about testing something like 0? Numerator will be -9 in that case, right? The denominator will be +81, so that's also, the number is always positive, exactly, yep, no matter what. So really the numerator is all that matters. And I'm pretty sure testing 4 is the same as testing -4 because you're squaring, right? So that will also be negative. So it's always decreasing, but it decreases in chunks, right? Because it doesn't decrease at -3 because there's an asymptote there. So you know that G is decreasing on -infinity to -3, -3 to 3, and 3 to infinity. I didn't actually ask this, so we'll say question Z, going back in the alphabet. is g of x even or odd or neither? Wait,
Odd.
the original function is odd. So it's going to have some kind of original symmetry, right? Okay. Find the relative max and relative min and indicate whether it's min or max. If there are none, explain why. So are there any local extrema for this guy? So there are none, as g prime of x does not equal 0, and g prime of x is only undefined at its vertical asymptotes. So there are no maxes and mins in this case. All right. Intervals of concavity. Which derivative do you look at for that guy? Second. So some meanie didn't give it to you factored, but can you factor it? What can factor out of the numerator? 2x. And it'd be x squared plus 27, right? Over x squared minus 9 cubed. So when is the second derivative undefined? Positive negative 3. When is the second derivative equal to 0? Just one place. 0. The x squared plus 27 isn't ever equal to 0, not for real numbers, right? Only for imaginary ones. And we do real calculus, not imaginary calculus. Okay, so we got 0, negative 3, 3, g prime sign.
Is that undefined at x equals a plus or minus?
Plus or minus 3. Okay, suppose we tested negative 4. That factor is negative, right? This next factor is positive. The denominator factor is positive. So second derivative is negative there. Okay, test negative 2. Negative first factor, positive next, I don't know why I can't close that parenthesis without making a positive 1. Positive next factor over negative. This would be 4 minus 9 is a negative number, and you cube a negative number, you get a negative number, right? So that's, second derivative is positive on that subinterval. Okay, how about 0 to 3? Say test 2. Plus plus over negative, right? So overall second derivative negative there. Testing 4, plus plus plus, yes? Plus. G is increasing, oh no, not increasing, sorry. G is concave up on what interval? Or else? Negative 3 to 0 and 3 to infinity, but, and G is concave down on negative infinity to negative 3 and 0 to 3. Are there any inflection points? Only at 0. Not at x equals plus or minus 3y. Since g of plus or minus 3 is undefined. No point on the graph at that point. I mean, the inflection does change at those points. It's just they're not points. They're asymptotes.
So would it be G prime of 0 equals 0?
Well, g of 0 equals 0 also. Right, because when you plug 0, because when you're asked to find the inflection point or the maxes and mins, I want to know what the points are on the original curve. It is the case that they happen to both be the same. All right, state the vertical asymptotes. Are vertical asymptotes x equals or y equals? And what are they? X equals positive negative 3. Yep. How about the horizontal asymptotes? This will be the limit as x goes to infinity or negative infinity of this function. What is that? It's very easy. Because the numerator's degree is lower than the denominator's degree, this is going to be 0. So y equals 0. Okay. And then sketch the graph. We have a every 1 point we know we go through 0, 0, right? We also know we have asymptotes though, don't we? 3s, yeah. So an asymptote at x equals 3, x equals negative 3. Sketches in a different color. Okay. Now you could just pick some test points, couldn't you?
I'm sorry, I might be mistaken, but we have a horizontal asymptote at 0.
Which is the...
Through the origin?
Yeah, you do. It's possible. You have to approach that asymptote as you go to infinity, as you get close to it, not necessarily right away. So what do you get when you say, like, plug in, I don't know, 1? Is it a positive or negative number? It's negative. So you plug in 1, and this, I think, is like negative 1/8 or something, right? And when you plugged in negative 1, you'd get positive. And also, isn't our function always decreasing? So doesn't it look, it should look something like this, right? And I think that there is an inflection point at 0, 0, and the function does change from concave up to concave down. Is that what happened? Okay. Now how about to the left of negative 3? Like say, like plugging in x equals negative 4. You plug in x equals negative 4, g of negative 4 is negative 4 over 4 squared is 16 minus 9 is 5, right? So you're below the axis, and also you're always decreasing, aren't you? So it has to be something kind of like that. And that is a decreasing function, right? As in, if you're only looking at that portion, you're on a chute as opposed to a ladder, right? And because of the original symmetry, because it's an odd function, you have to have your other half of the picture up there. So that's how a function could be always decreasing. Except for asymptotes. Okay. Now, really, graph sketching and all this stuff was kind of section, one thing it is in your L'Hopital's rule, to go back and add some of those in. Okay. So that graph sketching was really section 4.3 and 4.5, right? So the next thing that I think is kind of important is the max-min optimization problems. So you didn't have a test question like this, but you could do a question like this. So a box with an open top is to be made from a piece of cardboard that's 3 feet wide by cutting squares from each corner. Unless you're told the construction this way, the other box problems don't necessarily mean you're cutting out corners, so don't assume that. So you have cardboard, it's a square. This is 3 feet, this is 3 feet, and you take out pieces from the corners. Is the box gonna always have the same size? You're gonna make it's not necessarily gonna be a cube. So the size don't have to always be equal, not all of them anyway. Two of them are by default.
I call those cuts x,
We call those cuts x, yep.
and the distance between them is 3 minus x.
It's actually 3 minus 2x. You know, the volume is x times 3 minus 2x times 3 minus 2x. Because you cut out one from each corner, that's why it's 2x, right?
Yeah.
All right, and so then multiply that all together. X times 9 minus 6x minus 6x plus 4x squared. Or 4x cubed minus 12x squared plus 9x. You want to find the max, right? You know calculus. So how do you find maximums? You use the derivative, right? Where the derivative is 0 is where you could have maxes or mins, and you have to figure out which is which. So what's the derivative?
12x squared,
Minus?
24x
Set it equal to 0. Take out the best, greatest common factor you can.
3.
3. Okay. Minus 8x plus 3, right? If you can't factor fast, what's the method you revert to? I'm not going to go there because I don't have to. I know how this factors. I'm pretty sure it factors into 2x and 2x. And I'm pretty sure one of them is minus 3 and one is minus 1. It's a reasonable guess, isn't it? And I do think it works. Does it work? Do you agree? Because you get 2x times 2x is 4x squared, right? 2x times negative 1 is negative 2x. Then minus 6x makes negative 8, right? I mean, your options with 4x squared are either 2x and 2x or 4x and 1, right? There aren't that many options. And 3 is 1 and 3 or 3 and 1, right? There's not that much to pick from. So 2x minus 3 is 0. 2x minus 1 is 0. So what are the two answers? The first one is x equals, or 1.5. And the second one is x equals 1/2 or 0.5, same thing, right? One of those answers makes no sense. Which one? 1.5. If you do this, you'll have no box. If you cut 1.5 out of each corner and you only had 3 feet, you've cut the box into 4 pieces and you can't fold anymore.
Makes my job easier.
So no 1.5. So how could you verify that this is a max? What do you want to use? I mean, my own inclination is second derivative test if the second derivative is easy. Is the second derivative easy? Yeah. So the second derivative is 24x minus 24, right? And when you plug in 0.5, is the result positive or negative? Negative. And if the second derivative is negative, that means v is concave down. And picture in your head a concave down graph. If your graph is concave down at a critical number, then you have a max. So thus at x equals 0.5, we have a max volume. And did the question ask for how you're going to cut up? Oh, the question said find the volume that that box would have. Plug in x. Or you can kind of just like think about what it would be. If you took out 0.5 from each corner, so your height's going to be 0.5, right? What's the length and what's the width in that case? You've taken out 0.5, so it was 3 to begin with, right? So it's 3 minus, so it'd be 2, wouldn't it? Because this was 3 from end to end, right? You took out half of a whatever on each end, right?
Just put that 0.5 in.
You 3 minus 2 times 0.5. So the total volume is 1/2 times 2 times 2, or 2. And what were the units? So cubic feet, right? You could technically plug 0.5 into your V function, but I think that's harder. Does that make sense? Yeah. Okay, example 6 is also a box, right? But did I say that that box was constructed by taking cardboard and cutting out corners? No, I did not. So that means that you have a box. It has a square base and an open top. This might have been a test question. So I purposefully did not say cube. It's a prism, as in like, a right rectangular prism with a base. That's a square. Do you know that the height is equal to the size of the base? No. So you could have to give it a different variable. Call it H, call it Y. I don't care. I just tend to call it Y. It has to be a different letter because it could be different.
I'm gonna guess that cube is the maximum amount of surface area you need to get that volume.
If you don't have the open top. So if you don't have the open top, then it ends up being the case that you always end up getting a cube. The open top messes with it a bit. So the volume is x squared y. If you have an open top, all the sides count in the material except for the top. Does that make sense? So that's kind of like saying minimizing the stuff used is the same as minimizing the surface area. So how many sides would this box have if 5? It'd have 4xy, those are all the sides, and then plus an x squared. So those are your two equations. If the box had a top, it'd be 2x squared. Okay. What does the 32 tell you? To tell you about the volume. It tells you what x squared y equals. So 32 equals x squared y. And you can use that information, you can incorporate it into the A. You can either solve for x or solve for y. One is easy, one is hard. Solve for y. And so your area equation is 4x times 32 over x squared. And before you take a derivative, simplify it. What does that simplify to? Plus x squared. So there's your area equation. Do you want to find the min or do you want to find the max? You want to find the min. The minimum. It's like saying see an enemy. Aluminum. Okay, so to find the min, you take the derivative. So what's the derivative of 128 over x? Yay. And then plus 2x, right? If you set these problems up correctly, they should work out nicely. The problem with that test that you took on this stuff is if you didn't set them up right, it took you forever because it was just so nasty. So if you get something super nasty, you probably made a mistake. So 0 is minus 128 over x squared plus 2x. Personally, what do you, I would add the 128 over x squared to that side. Say that again? So 128 will equal 2x cubed. This was meant to work out. X cubed is 64, someone tried. X equals 4. Huh? Clever. Okay, and since, what's A prime prime? Because we have to verify this is a min before we sort of move on. You can't just say it's positive, you just tell me what it is. So if you differentiate negative 128 over x squared, you get positive 128 times 2, so 256 over x cubed plus 2, right? That's not very hard to do. And if you plug in 4, is the result positive or negative? So A is concave up, and in your head picture a concave up curve. That means you have a min. thus min. Woohoo! Okay. Hmm? Say that one more time, Mary Kate first, then you. Dimensions, yep. So the dimensions, were you asking the same thing, Natalie? So the base is 4 meters by 4 meters, right? How would you find the height? Yep. Height would be y, which is 32 over 16, or 2 meters. It's a big box, yeah. 4 meters is huge. Okay. I am going to X-nay example 7, and I'm going to make up some L'Hopital's rule problems because that will probably be on your test, okay? So just scribble 7 out and I'm going to make some problems up.
I was halfway through solving the answer.
I'm so sorry. You get a gold star for the day, okay? Example 7 new. So find limits. So when do you use L'Hopital's rule? 0 over 0 or infinity over infinity. So is this one 0 over 0 or infinity over infinity or neither? It's 0 over 0 because 2 to the 0 is 1, cosine of 0 is 1, sine of 0 is 0. So it is actually 0 over 0. Okay, so H it. And this rule does not say use the quotient rule. It says take the derivative of the top over the derivative of the bottom. So what's the derivative of the top? Plus sine x, great, over, you did not do the quotient rule. That's not what the rule says. It says derivative of top or derivative of bottom. Okay, is it 0 over 0 anymore? No. Now you can plug in 0. So you'll have ln of 2 over 1, I think. So just ln of 2 is what that limit is equal to. Right? Woohoo! Okay. Limit x goes to 0, e to the x minus 7 over cosine of x. You just put 0 in, don't you? This is not 0 over 0. Don't do the rule, it's going to fail. Okay, the rule only works if it's 0 over 0. So this will be 1 minus 7 over 1 or negative 6. Direct input, fine. And like, look at your test. Like I tried, there was one question where you had to use the rule, and then there was one question where you had to know that, oh, it's not 0 over 0. I just plugged the number in. Like, that was intentional. Now the other question on yours was something like this. Find the limit as x goes to 0, to make sure I construct it correctly. 1 plus 3x to the 1 over x. Or something like that, approximately. I know, these are tricky. So you start, but they're really doctored to work out well. So start with defining, and this is a weird indeterminate form. If you plug in 0, I get, and I probably should even say 0 plus just to be specific. But when you plug in 0, your base is 1, right? And if you do 1 divided by a small positive number, that makes infinity. So, and 1 to the power of infinity is not something that is consistently the same thing, any more than 0 divided by 0 is the same thing. So you've got to somehow manipulate this expression so that you can use L'Hopital's rule. To use L'Hopital's rule, you have to have a fraction. And so the trick for something like this is to use a logarithm. So natural log of y is natural log of 1 plus 3x to the 1 over x. Notice y is the original expression that I'm limiting. That's the thing I'm looking at originally. And a lot of you got the whole, like, that 1 over x pulls down. But then you tried to, like, apply the product rule to it or some kind of craziness. Like, that actually is the same thing as ln of 1 plus 3x over x, isn't it? It's a fraction. Can you find the limit of that fraction as x goes to 0? Let's check. The limit as x goes to 0 plus of this thing, is it 0 over 0 or infinity over infinity? It's 0 over 0. I tried to make one that was easy. Don't use the quotient rule. That's not the right thing to do. What's the derivative of the numerator?
3 over 1 plus 3x.
Do you guys agree with that? 3 over 1 plus 3x? The second, the 3 in the numerator came from the chain rule, right? What's the derivative of the x?
1.
Okay, and now can you plug in 0? Yes, so that limit is just, so 3. So what this told you is that the limit as x goes to 0 plus of natural log of y was equal to 3, where y is your original expression. How do you undo the ln? You e it. So the limit as x goes to 0 plus of regular y will be e to the third. You got almost all the credit if you got to 3. Some of you ln'd again, which doesn't you have to undo the ln'ing that you did earlier. So that's the most complicated L'Hopital's rule problem you're going to get. So, okay.